Today, the topic of my presentation is oleic acid. It is a fatty acid that occurs naturally in various animal and vegetable fats and oils. It is an omega 9 fatty acid. It can be made by the body, also found in foods. Highest levels are found in olive oil and other edible oil. It is an odorless, colorless oil, although commercial samples may be yellowish due to the presence of impurities. In chemical terms, oleic acid is classified as a monosaturated omega 9 fatty acid abbreviated with a lipid number of 18:1. This is the formula of oleic acid. The name derives from the Latin word oleum, which means oil. It is the most common fatty acid in nature. The salts and esters of oleic acids are called oleic. It is a common component of oils and thus occur in many types of food as well as in soap. This is the structure of oleic acid. Then manufacturing of oleic acid. A process for producing a high purity oleic acid composition utilizing enzymatic hydrolysis is disclosed. The process involves obtaining high oleic sunflower seed oil which contain triglycerides having fatty acids moieties of oleic acid in an amount of 60% or more, preferably 80% or more. Further, where in the ratio of linoleic moiety to oleic moiety is less than about 0.25 and preferably less than about 0.09. The oil obtained from the high oleic sunflower seed oil is subjected to enzymatic hydrolysis by contacting the oil with hydrolase enzyme or various combination of hydrolase enzyme within an aqueous medium at a temperature in the range of 20 to 60 centigrade and a pH in the range of about 4.5 to about 10. The oil, hydrolase enzyme, and the water are agitated so that hydrolysis occurs at the oil-water interface, and the acid moieties of the triglycerides are separated away. An oleic acid layer is allowed to form and separate away from the aqueous medium, and the aqueous medium is then separated away to provide a highly pure oleic acid composition. Application of deputatic solvent as a catalyst for the esterification of oleic acid with glycerol. Free fatty acid in low-grade oil could be reduced by using an esterification reaction with glycerol, which itself is a waste product of biodiesel synthesis to give mono and diglycerides. This study investigated for the first time the reaction between oleic acid as FFA with glycerol using a phosphonium-based eutectic solvent as a catalyst. The effects of temperature and the DES catalyst concentration on the esterification efficiency of fatty acid conversion were observed. The glycerol 1 to fatty acid molar ratio and agitation speed were kept constant. The results reveal that the lowest activation energy of 54.64 kg per mole was attained using 5% of DES catalyst. According to optimum reaction conditions were found at a temperature of 150 with a 5 DES catalyst which produced 95 FFA conversion after 30 minutes of reaction time. In addition, 85% of combined mono and diglycerides were observed at the optimum condition which will be easier to transesterify using alcohol. The process were repeated without adding any fresh catalyst and results showed that catalyst activity sustained very well, suggesting that it can be reused a number of times.